Hello everyone, welcome to this video. In this video, we'll be solving another question from the paper IIT-JAM 2020. This is a 2-mark question and this is a multiple choice question. So here in this question, they are saying that if M is given to be some real 6 cross 6 matrix, the matrix that is not known to us directly, but the order is known to us, that is 6 cross 6, and 2 digits are given to us. Let 2 and -1 be the 2 eigenvalues for this matrix. So it's 2 among 6 eigenvalues is given to us. Now they are saying if m raised to power 5 is equal to A times the identity matrix plus B times the matrix M. Obviously the order of identity matrix would be 6 cross 6 only, where this A and B, they are some real numbers. Then what is the value of this real number from the information that is given to us? So here the solution is pretty simple. All you have to know is use this polynomial in order to get the values of A and B. Now you could write this polynomial as m to the power 5 minus b times the matrix m minus a times the identity matrix, that is equal to the 0 matrix, right? This is the given polynomial in M. Now we could just substitute the one eigenvalue that is given to us as 2, right? Let let lambda 1 is equal to 2 and lambda 2 is equal to -1 be the 2 eigenvalues that is given to us. 2 eigenvalues of M. Then I would say then these eigenvalues would satisfy the given polynomial. Why this is so? This satisfy the polynomial 1, right? Now why this is so, that is an important question here. So let first of all solve the question and then I'll tell you what is the reason behind this one. So if these lambda 1 and lambda 2 satisfies the given polynomial, that means when you substitute these polynomials in the given these values in the given polynomial, you would have, so let put lambda 1 is equal to 2 in polynomial 1. So in that case you would get 2 to the power 5 minus b times multiplied with 2 minus a, that is equal to 0, right, in terms of elements. So 2 raised to power 5 is 32 minus 2b minus a is equal to 0, or in other words you have a plus 2b minus 32 is equal to 0. Mark this as equation number 2. Now let's substitute another value of lambda here. Lambda 2 is equal to -1 in the equation 1. So that you would have -1 raised to power 5 minus b times multiplied with -1 minus a, that is equal to 0. So when you solve this, you have -1 plus b minus a is equal to 0, or you have a minus b plus 1 is equal to 0. So let's mark this as equation number 3, right? So now from solving these two equations 2 and 3, you could directly calculate what is the value of A and what is the value of B. So let's solve this using the method of elimination. So we have a plus 2b minus 32, that is equal to 0, and you have a minus b plus 1 is equal to 0. So let's subtract these two equations over here. So these two cancel out. Here you have 3b and here you have minus 33, that is equal to 0. So when you solve this, you simply get the value of b as equal to 11. So once you have the value of b, let's substitute it back in equation. Put b is equal to 11 in equation 3. So that means you have a minus 11 plus 1 is equal to 0. So that means a minus 10 is equal to 0, or you have simply the value of a as equal to 10. So from here you simply see you have a as the correct option. A is the correct option. So right, so here in this case, this is how you work out the solution. Now, why we have chosen this particular method and very simple method in order to solve this question? So here you see why this is a polynomial in the given matrix which is having order 5, however the order of the given matrix is 6. So clearly this is not the characteristic equation, right? If this is not the characteristic equation, so can we say, so the question here is, can we say the eigenvalues of the given matrix, the eigenvalues of the given matrix would satisfy a polynomial, would satisfy a polynomial of lesser degree in that matrix only, of that matrix. Is it true? Is it always true? So let's have a look at this one. So the answer to this question is yes, it is always true, but note the converse is not always true. The converse is not true. That means, that is, every root of the polynomial in given matrix, polynomial in given matrix is not necessarily its eigenvalue, right? So how this is there? How? So let's see this through the proof. Suppose let's take the given polynomial only. So we have m raised to power 5 minus a times of m it is minus b times of m minus ai. So it is minus bm plus ai, that is equal to the zero matrix, right? Okay, so this is what you are given with you. Now you see, for if I say lambda is an eigenvalue of the matrix M with x dot equal to 0 as its eigenvector, in that case, according to the definition for eigenvalues, you have mx is equal to lambda x. This is the definition. Now you see, what would be m square x? You could write m square x as m times m of x, right? So what is m of x using this expression 4 here? It is lambda x, right? So lambda, because this is a scalar, you could take this lambda out, so it would be m of x only. And again you could apply equation 4 here, so it would be lambda into lambda x, so it would be lambda square x. Similarly, you see what would be m cube x, so it would be m times m square x. Now you see, what is m square x? It is lambda square of x, right? So because lambda is a scalar, you could take this lambda square outside and you will be left with m of x only. So you see lambda square lambda x, which is nothing but lambda cube x. So you could keep go on doing like this, and finally you will reach at a conclusion that m raised to power n of x, that would be nothing but lambda raised to power n of x only. So using this expression here, if I apply this polynomial onto some member x which is not 0 and which is some eigenvector, so it would be m raised to power 5 minus b of m minus ai applied onto x, that would be 0 of x, which is nothing but 0 number. So this is a number here, right? So it would be m raised to power 5 x minus b m x minus a x, that is equal to 0, right? So here in place of m raised to power 5x, you could write lambda raised to power 5x, right? In place of mx, you could write lambda x, and minus ax would be as such. So that would be lambda raised to power 5 minus b lambda minus a applied onto x, right? Or in terms of the numbers here. So it is because x is non-zero, so this obviously has to be 0. Lambda raised to power 5 minus b lambda minus a, that is has to be 0. So you see, we started from some polynomial in the given matrix of lesser degree than the order of the matrix, and we reach at the same polynomial with the matrix replaced with its eigenvalue lambda with the same expression. So this is why we could use and just substitute the eigenvalues in the given matrix. So I hope you understood this, the trick behind this question as well as the reason behind it. Well, that is it for this video. Thank you for watching.